Okay, so here's the exam B skill cards. So solve. Express your answer in exact form as a fully condensed logarithm. So the fully condensed logarithm means that we're going to have to multiply at the end by log base A of A. Okay, so when it says fully condensed log, you know you're going to have to do that move at the end. All right, and I'll come back to that. So, okay, so the first step, we're going to have to add the 1. So that gives us 5e to the x plus 2 equals 3. Then we have to divide by 5. So e to the x plus 2 equals 3/5. Then you have to convert to a logarithm. And the way it goes is you take the exponent. So x plus 2. This is equal to the exponent. So this is the exponent on base e to get 3/5. But the exponent on base e, that's ln. So x plus 2 equals the natural log of 3/5. Then you have to subtract the 2. Okay? And then this is the step where you're going to have to multiply by log base A of A. And the A is whatever this first log's base is. So this term is a log, that term is not. So we're going to multiply it by log base E of E, which is natural log of E. Okay, there's like an invisible base E on a natural log. And when you do that move, the exponent out front, I'm just going to cross it off and put it inside. I'm sorry, it's a coefficient out front, and I put it inside as an exponent. Okay, so let me write this nicely. Okay, and then natural log of 3/5 divided by e to the second. Okay, but this is e to the second over 1, and I got to do keep, change, flip. So I'm going to multiply by 1 over e to the second and cross that off. Okay. All right, so that's the answer to that one. The next one is, it's the same thing, except it's not a base of e, it's a different base. Okay, so that's this next one here. Solve, express your answer in exact form as a fully condensed log. And we're going to start by adding 7. So this is 2 times 7 to the x minus 1 equals 20. And then divide by 2. Okay. And then you have to switch to a log. So I'll do this optional, like in between step, but you take the exponent, you write it down, and then you say this equals the exponent, and really think it through, guys. It makes a lot of sense if you really like think it through. What is this binomial in this context? It is the exponent on a base of 7 to get 10. Okay, just like think it through logically. And then exp base 7 that's the same as log base 7. And you can go right to this, guys. You don't have to do the exp move if you know. Then I will add the 1 over. Okay, and because of those instructions that said express your answer as a fully condensed log, we have to do multiplying by log base A of A. Okay, so we have to do this same like move that we used last time, multiplying by a log. That's where the base is the same as the inside. That's the move. Okay, so This is a log term, that is not. So I'm going to multiply by, in this case, log base 7 of 7. Yeah, and this move is hard to remember, guys. I know, and part of the reason it's hard to remember is because we don't really have like a word for it or like a name for it, but maybe you could call it this. Okay, if it says fully condensed, I know I'm multiplying by log base A of A. You know, I know I'm multiplying the term that is not a log by log base A of A, and then going from there. Okay, we could call it the log base A of A trick or something like that. Okay, this is just a 1, so I don't really have to bother moving it inside. Because it's like optional to even have it. So this is log base 7 of 10 plus log base 7 of 7, log base 7 of 70. Okay, now this next one. So these ones are like the reverse of the previous. Okay, so we're gonna solve, express your answer in exact form. So it doesn't say like fully condensed or anything because our answer is not going to have a log in it. The original equation already has a log in it. So that means we're going to have to get the log to cancel to get our answer. Because the x is inside of the log. That's why we have to, maybe not get it to cancel, but we have to rewrite it in exponential form. Okay, so I'm going to add the 20 first. So I have 5 natural log 8x minus 5 equals 25. And then divide by 5. Okay. And then from there, you put, you could, okay, so now to translate, if you're not sure what to do, this could help. So ln is the exponent on base e. Okay. The exponent on base e to get this is 5. And guys, even if you kind of like ignore that for a moment and just read it, the exponent on base e is 5. The exponent on base e is 5. That tells you right there how it goes. It's the exponent on base e is 5. So I open up a base of e. The exponent on it is 5. And when we do that, we get this. Okay, so I'm translating from log form to exponential form. Okay, and then you could solve. So I'm going to add 5 to both sides. And I'm switching the sides of the equation at the same time, just because I like my x's on the left. And then you divide both sides by 8. And you get that. Okay, and exact form means you don't use a calculator. If you plug this into a calculator, you're going to get a decimal. This is a number. It's an irrational number, though. That's why we have to use e, because e is an irrational number. So, next. Oh, all right, I guess I'll do this. This is similar. This is almost exactly like number 1. Except the difference is that you do not need to condense your answer. Now, if you're practicing a lot and you're just kind of in the groove of condensing, that's fine. You know, if you end up condensing, you wouldn't get points off, but just pay attention to whether you have to or not because it could save you some time. And, all right, so this one here, I'm going to add 1. So we have negative e minus 6x equals negative 5. Okay. Then you have to divide by negative 1 because this negative, even though the 1 is invisible, this is a negative 1 out in front. So I'm dividing both sides by a negative 1. 8 to the 10 minus 6x equals 5. Okay. And then I have to translate to exponential form. So what is the exponent? The exponent is 10 minus 6x. So I'll write it down. And then I'm going to say to myself, this is the natural log of 5. All right, now let me break that down real quick. If you don't know how I got that, what I did is I was like, in my head, I said, this is the exponent on base e to get 5. All right, I just kind of thought that through like in my head. That's what this binomial is. The exponent on base e to get 5. All right, then I'm going to subtract 10. Oh, this is why you don't have to condense it, because it'd be too complicated. So we're going to subtract 10 and then divide both sides by the -6. Okay, let me look at the answer. All right, now guys, a lot of times people don't leave a negative in the bottom. So if you took this negative and distributed it on top instead, that's a good answer also. So, but that is the one that I put in the skill cards. Okay. Next, we've got an absolute value equation. All right, so with absolute value equations, so we've got 5 plus 6. You're going to have to get the absolute value bars to drop at some point. So there's a move we've got to do for that. Guys, I just want to point something out. When people are going on a test, and they're just kind of flying through, if you're not being careful, some people might add the 5 and the 6 together, but that is not, you do not want to do that. The 6 is part, this is a term by itself, the 5. Okay, that's a term in and of itself. And then this is a term as well. So the 6 is part of the absolute value term. So we're going to have to subtract 5 first and then divide by 6. So if I subtract 5, then I get this. And then I divide by 6. Okay. And then we've got to drop the absolute value bars, which is totally, you could do that if you go plus or minus on in front of the right side. Okay? Because absolute value means distance from 0. And remember, if a thing is, a certain distance from 0, it could be to the right of 0 or to the left of 0. So that's why we do plus or minus, because that shows the two possible locations on the number line. Okay, and then you split up into 2 equations. And solve. Okay. All right, so there's that. So now the next few problems, we're going to be combining absolute value equations and exponential and log equations. So it's going to start out as an exponential or log equation. Like this one starts out as a log equation, but there's going to be an absolute value within it that we're going to have to do the plus or minus move for. All right, express your answer in exact form. Okay, so first I got to get the natural log by itself. So I'm going to add the 6. So 2 natural log. -4 when I add the 6. Then I divide by 2. Equals -2. Okay. So this is the base. So we're going to convert to exponential notation. So e is the base, -2 is the exponent. E is the base, -2 is the exponent, and then what's inside of the log is the answer. Okay. So now I'm going to drop the absolute value bars, but when I do that, I got to do a plus or minus in front of the other side. So I'm dropping the bars, but I gotta go like this. Okay. Oops. All right. Okay, so now I can split this up. Okay, and then you do the same moves in both to get the x by itself. So I'm adding 8 and then dividing by 8. Okay, so that's one of the answers. Okay, and there is the other one. Alrighty, now this next one, solve, express your answer in exact form. Now this is an exponential equation, and so were numbers 1 and 2. Numbers 1 and 2 said to condense your answer. Number 4 is another one, but it said you don't have to condense your answer. This one is not being specific, so you don't have to condense. You only have to condense your answer if they explicitly say to. So we're going to solve it like we would any other exponential equation, and then we're going to have to do the absolute value thing, the plus or minus move. So 7, I'm going to subtract 3 from both sides, and then divide by 7. Okay. Alrighty, and then the absolute value of 1 minus x is equal to natural log of 10. This is the exponent on base e to get 10. Then I can do the plus or minus move and drop the bars, and then I can split it up. Okay, and then I'm subtracting 1 and then dividing by -1 in both cases. And you know what, guys? When you divide by -1, I just want to show you something. When you divide this whole thing by -1, you're dividing each term by -1. So that's going to just make them positive. All right. Now, if you showed your answer, if you just divided by -1 and then you left it like that. Okay, yeah, I didn't leave it like that. But that would be fine. All right, and then over here, x equals negative natural log of 10 plus 1. Okay, so there's the two answers. Okay. So we just did 7. And now, okay, now we're moving into the fraction stuff. So this is where all of these we got to get the GCF for. Or not GCF, I'm sorry, LCD. All right, so combine and simplify. So I look at, let me write this first one down. We've got 2 over 2x plus 1 squared minus 2 over 3. Okay, so for the LCD, I need to include a 3 for that, to cover the 3. But then I also need to cover 2x plus 1 squared and 2x plus 1. And the thing that would cover both of them would be 2x plus 1 squared. Okay, so that's the LCD. So this denominator here is only missing a 3. And then this denominator here is missing a 2x plus 1. So, okay. Alrighty, now, all right, guys, you're going to have to be extremely careful because there's a minus. So you're going to have to, at some point, you're going to have a binomial here, and you're going to have to distribute a negative. So let me think. All right. Well, so anyway, this is 6, and then here, this is going to be 4x plus 1. So when I distribute this 2, or plus 2, when I distribute this positive 2, the parentheses, I still need parentheses because there is another thing to distribute. So usually when you distribute, we drop the parentheses, but if there is another thing that needs to get distributed but hasn't been yet, then you've got to keep the parentheses. Right, I'll explain it that way. Okay, so now I have common denominators. Right, those are both the same. So I can make one big fraction. The denominator will be the LCD. That's why we got the LCD. Okay, and now up top, I've got a minus in the middle, and I've got a 6 over here, and I've got a 4x plus 2. So now I have to distribute that negative. Okay, so 6 minus 2, that is 4. All right, so I'm getting negative 4x plus 4. All right. Now, guys, it says to simplify. So what you want to do at this point is factor the top and see if anything cancels. So I could take out a negative 4 from the top, and then I've got x minus 1 on the inside. Okay, now since nothing actually ended up canceling, that was an optional move. You did not have to do the factoring if you saw already that nothing was going to cancel. Oh, like you see in my answer, I didn't do the factoring because nothing canceled. So either of these would work. All right, so you could say this, or you could take it a step further. It is a good habit to factor, but again, if you could just see that it's not going to help you, that it's not going to lead to anything, then you don't have to. All right. Now, this next one. So same idea, combine and simplify, but we're going to have to factor first before we can find the GCF. So here we've got, and I would, any binomials that you have for your numerators, wrap them in parentheses. Okay, now I've got a factor, and I'm going to go fast, guys, with the factoring, but please, you take your time with it. Pause the video if you need to, but this should not be confusing, like how I got this. So pause the video if you're not sure, take your time, and you'll get it. X plus 3, x minus 3. All right. So in this case, for my LCD, I've got to cover x plus 1. Or I've got to include an x plus 1 to take care of that. Then I need an x plus 3. But by including this x plus 3, I am covering both of those. So I don't need another one. But what I have not covered yet is this x minus 3. Okay, so that's the LCD. Now, guys, you could skip over this part, but if you're confused, I just want to do something I think a few people might be confused. So let me just real quick go like this. Denominator 1, denominator 2, LCD. This is another thing that we've done. Okay, so for my LCD, I need an x plus 1. So I can cross out one of them from each column. And then I need an x plus 3 and I can cross off one of them from each column. And then I need the x minus 3. So that's another way you could figure it out. Okay, so this one is missing the x minus 3. This one is missing the x plus 1. Okay. All right, guys, now I'm going to do some distribution on the top, and I got to be careful because of this minus. So when I distribute these, but the result I need to keep wrapped in parentheses. So guys, I just want to, no, I won't say that, sorry. Okay, so, all right, parentheses, x squared plus x minus 1. Okay, so that's what that is. And these middle ones, guys, cancel. This is like a difference of two squares backwards. Or it is. It is that. So that's just x squared minus 1. You don't even need those. All right, and then this one here, I'm going to do it fast. So x squared minus 3x minus 4x. Okay, I'm holding that in my head. Minus 3x minus 4x, that's minus 7x plus 12. Okay, so I skipped showing a step there. Okay, now, big fraction bar, x plus 1, x plus 3, x minus 3. This subtraction is in the middle, so that's coming down. Over here, we've got x squared minus 1. X squared minus plus 12. Okay, now I have to distribute that negative. So x squared minus x plus 12. Okay. And then combine like terms. So these are canceling, and we've got negative 7x plus 13. Okay, and I look at the top, the only factoring option that I really have would be factoring out a negative 1, but I could see that nothing is going to cancel even if I do that. So I'll just leave it. Okay, 2 more. All right, so 10 and 11. Need another paper. All right. Okay. Alrighty. This one here. So, guys, what we've got going on here is we've got backwards binomials. And if you've got a backwards binomial like this, write it forwards. And then if the leading term is negative, factor out a negative 1. So this is actually, I'll write it over here. So we've got 4x minus 1 over negative 1. Okay. All right, guys. So now you could see that the least common denominator is negative 1, 3x minus 1. Okay. So this one here is just missing the negative 1. So now I go to a big fraction bar, negative 1, 3x minus 1. Okay. And then, so I'll distribute this here. So I've got this subtraction right in the middle. And then I'm carrying these down. And then I just keep distributing, combining like terms until I can't anymore. So I can distribute that. And we get negative 5x minus 3, I hope. Yeah, okay. Negative 5x minus 3 over negative 1, 3x minus 1. And then, remember guys, you want to simplify completely, so see if anything cancels. And I look at the top, and I could take a negative 1 out of the top. And in this case, it makes sense to do that because I'll be able to cancel the negative 1s. All right, so those are canceling. So the answer is that. Okay. All right, so we have a similar problem here. And then that's the last one. So you identify the backwards binomial. It's this one right here, if you see one. So that's negative x plus 10, which is negative 1 x minus 10. Okay. And then you want to factor. So we've got a difference of 2 squares in this denominator. So I'll move over here now. 4x plus 1 plus 9x. All right. And, okay, so LCD. So for the least common denominator, we're going to need negative 1, x minus 10, and then that x minus 10 is going to cover that one as well, and then x plus 10. All right. So this one is missing an x plus 10. This one is missing a negative 1. Okay. All right, let me do a little bit of like simplifying up here. All right, so that's 4x squared. And I'm going to skip a step, guys. I'm going to hold the middle terms in my head and add them. So my two terms in the middle are going to be 40x and 1x. So 40x plus 1x is 41x. And you don't have to do it that way. You could actually write the whole thing out, but I'm just saving some space. Okay, yeah, and then this is going to be, I'll just put that there. So that's a negative 9x. Okay, so we've got 4x squared plus 41x plus 10 minus 9. Okay, and I can do some simplifying. So 41 minus 9 is 32, I think, plus 32 x plus 10. Okay. Yeah. And then this is all over negative 1. Okay. Now you try to factor the top. And guys, if shoot. All right, never mind. I was going to show you kind of a new move, but it's too close to the midterm. Okay, so try to factor the top. We could take out a 2. So 2 And then 2x squared plus 16x. Oh, sorry. Wait, yeah, 2x squared plus 16x plus 5. All right, so guys, up here though, what am I doing? Okay. Yeah, so the only difference between my solution and this on the back is I had the negative, I put this negative up top, but you don't have to do that. You could leave it on the bottom. Okay, guys, there it is.